say about ROI in test automation. And this goes to a conversation I had last night with one of the other speakers here at the conference who referred to QA as a cost center. And my assertion is that QA is not a cost center, and it never was. QA is a fundamental part of engineering and feature development, which generates revenue. And we need to push back on the notion that that is not true. If you think about any physical object that's being manufactured, start with Lego. Can you imagine the quality assurance processes that Lego goes through with the precision that it's made compared to any other plastic injection process? It's second to none. And there's no way a company that produces such high quality considers their quality to be a cost center. Same with airplanes, same with anything where lives are at risk. Well, lives are frequently at risk with software. It's not a cost center, it's part of engineering. So what does return mean for QA tooling and QA investment? Return means to me more than benefits, more than just cost. Because a lot of cost, if you Google ROI calculator for test automation, you'll find 5 or 6 different answers. And all of them are kind of, they're not bad. I mean, they all talk about cost. And I do think it's important to understand cost. What I think is much more important is to understand impact, overall impact, especially after you've shipped the product. And the fact that it can transform the nature of your company once you've done it right. So it's not bad to start with cost, but I was disappointed to find that none of the 5 calculators I looked at even went beyond cost, ever. There's one done by SmartBear that looked at defect escape prevention, which is definitely in the right direction. It's good stuff. But I want to go much further in terms of the conversations that we're going to have. So to me, return is team efficiency and productivity, which we all know that when QA is firing on all cylinders, the team is much better, much more confident in their ability to release. Being able to prevent escapes, being able to impact the user experience in a meaningful way. How many times have you downloaded a game that doesn't work very well in the first 3-4 minutes and you just don't ever run it again? Or it's too many ads or something like that. Nobody's watching sometimes for the user experience. They're not watching the impact of that. And MAUs drop, monthly active users drop, and daily active users drop. And you see the impact of a poor quality experience immediately. And that is definitely a potential benefit for ROI. We can also help release frequency and post-production reliability. The holy grail to me is being able to incorporate user behavior into feedback loops that tell you what you should be testing in the future. Because you always have a hypothesis about how your users are going to behave, but it's not until you study analytics to find that until you find out that how they actually used it, as opposed to what your prediction was about how they would use it. So this cost center is definitely punching above its weight class, right? We QA, we are a force multiplier for engineering. We protect revenue, we create value, we identify, mitigate, eliminate risk. My career assertion is that the more you talk about risk, the more visibility your projects and your career will have at higher levels in your organization. Problem is, this all assumes that we're getting it right, and we don't often get it right. We have customer statistics internally at Sauce Labs that say that I think 30% of our customers tolerate something in the neighborhood of 40% failure rate on their automated test runs. I'll get to that in a minute, but let's all agree that that's bad. So my assertion is that automated tests should not be manual tests that are simply converted to computer tests. They're fundamentally different. They look at different things. They're not capable of doing what the human can do. Not yet, possibly not ever. I'm in the skeptical camp on that one. We prefer simple tests over complex tests. Test one thing. Test it well. Make sure you're actually testing it. Tests should be done at the lowest layer that will deliver value. If you're doing a UI test to look at some sort of online calculator, like a mortgage calculator or something like that, and you're using Selenium to populate the form fields, and then you hit submit, and the form goes to the server. God, I hope it's actually doing it client side. Let's just say it goes to the server, and it returns a result, and you have your number there, and you're using Selenium to fill out these numbers, and then you're asserting on the text that's displayed in the thing, and then you do that 40 more times to do different kinds of refinance analysis and mortgage and stuff like that. That is not doing the test at the right layer. The test should be done at the layer that will produce and allow you to operate on the data, the calculations, and all you need to do with the UI is make sure that the UI is capable of rendering what came back from the API. You do that 2 or 3 times, you're done. Everything else should be at the API layer. It's faster, it's more reliable, and I don't have enough time to go into excruciating detail about how much time and resource you're wasting if you use Selenium for that tool. And finally, test what the money wants. I once had an offshore team go nuts. I was on vacation. I went away for 2 weeks. I came back, and they had written 250 tests that operated upon the user's, Selenium tests, operated upon the user's ability to edit their profile on a, not even a social media site, an e-commerce coupon shopping site, Retail Me Not. And I wasn't upset about it because I didn't think about it much. I just thought, oh, 250 tests, fantastic. And then the analytics people came to me and said, fewer than 1% of our users ever use that feature. Meanwhile, you have 20 tests on the store search algorithm page, which is 99.5% of our revenue. So test what the money wants. You can, if you do this, you will test less, more frequently, more effectively, and you will be certain you're getting a return on your investment. So let's talk about things that can actually pull you back and cost you more. Because once developers lose trust in automation, it is really hard or impossible to get it back. Chances are they don't have trust in the automation to begin with, if you're like me. So failing tests, tests that you tolerate failure. Flaky tests where sometimes it'll pass, sometimes it'll fail. Poorly documented tests where nobody knows what's actually doing. Tests that haven't been looked at, in a year, a certain amount of time, something like that. Tests that can't fail. Tests that can't fail. You ever had this before? Has anyone had this before? I got an email from my boss once at Retail Me Not who was like, hey, Marcus, only 37 tests passed in that out of 800 in the last build we ran. And I was like, yeah, we're having some environmental, some instability issues. He's like, if the site is down, how did 37 tests pass? Valid. So here's the thing. If you have a test that's failing, you're not fixing it. You don't know why it's failing. You tolerate its failure. You don't understand its state. You don't know what it's testing. You don't even know if so a test should only pass if it can pass. It should only fail if it can't pass, right? That's a simple statement, but it's true. If you have all these conditions, not only are you getting no return on your investment, but you have the impression that you have coverage where you don't. So it's a negative value. You are misrepresenting to management the risk profile of your test automation and the software you're shipping. So you can't have ROI when these things are happening. Now, there should be a tolerance for failure because the product changes, systems are flaky, and life happens, right? But that tolerance should not exceed your ability to address it, if that makes sense. If you have someone whose job is to fix automated tests in the morning for 2 hours, and there are more failures than they can address in that 2 hours, then there's a problem. Because tests are going to fail. That's what they're designed to do. Tests that always pass, they're probably valuable, but you should make sure you're keeping up with whether or not they're still relevant. So these are just wastes of time. Not all passing tests add value. If you have 800 tests and they're 400 of them, or they're just sort of mulching over the same thing over and over and over again, they're not adding value. They're just taking time. Selenium tests are super expensive in terms of test automation. A unit test can run at about 1,000th of a second. Selenium tests, depending on factors, can be between 10 and 45 seconds. If you're doing it right, they could be up to 10 minutes if you're ignoring all of our advice. And test results need to be analyzed. Without analysis, you have zero ROI. You don't even know what you're doing. If you have these things going on, it's not entirely likely that you're contributing the value that you think you are. If these things are going on, your tests are worthless. All right, so here's what I want to do. I have a calculator. It's a nice spreadsheet. I can even show it to you. It basically takes this cost and time thing. It says the number of tests, number of minutes it takes for a manual tester to execute the average test, the average cost per minute of a manual tester, how many times do you want to run that per day, and then how many days are there in a week? Are you testing 5 days a week, 7 days a week? And it's not meant to show you a return on investments. It's sort of meant to help you understand the theoretical value you're getting, because nobody's ever going to run an 800 test suite of manual tests 8 times per day when there's no compelling reason to do that. Nobody will do that if they do run. The interesting thing, though, is that as you add more tests, you think you're saving more money. That's the problem, right? If I add 20 tests to my 800 test suite and I've now just saved whatever 20 times 100 times 15 minutes of time is, I've just offset all that manual effort. Isn't that great? Well, still, you're discounting the concept of value of the tests. If they were meaningless tests, not worth it. So then we need to add, once we move from cost and time, just pure cost and time, we need to add these constants: maintenance, development, framework development, all these costs that we know is happening. So when you maintain separate test environments, that's going to trickle away from the benefits you're getting. All these different things, especially if the environment is managed specifically for test automation. If it's an ephemeral environment, it's going to be very, very, very cheap to operate, but there's a good chance it was expensive to develop. You got to factor that in. So ephemeral environment's fantastic, but still, that stuff is not plug and play. Certainly not in the world we live in just yet. Hopefully within a few years it will be at that point where it's plug and play. Productivity should not be underestimated. What we want to do is factor in things like, I have a suite of API tests that I, as a QA person, have contributed to the main code base for the microservice I'm working on. I've done 20 different tests that iterate over the data that's being calculated from my mortgage calculator or whatever. And I hand those to the developer. Every single time they do a change, I'm able to do these contract tests in 1 second. And developers can execute them themselves. That makes those developers so much more productive, because they probably already wrote their unit tests. Please, God, tell me they all wrote their unit tests. But if they didn't, you have this thing to hand them that adds a little bit more increments. If you develop these integration tests for your developers on a microservice, then they can be so much more productive when they are developing these kinds of things, right? Production defect mitigation. Let's incorporate that into ROI. I used to do this all the time. I would think to myself, oh, I have a little problem. API contract changed, and as a result, they broke something with an existing integration. And me catching that now, I just saved the company $20,000. Nobody will ever give me a bonus. Nobody will ever notice it, but just save the company that much money. It wasn't just time and productivity and the cost reduction and the fact that I offset manual effort. It's the fact that they didn't catch that bug a week from now or a month from now, or didn't end up on the front page of the New York Times because we couldn't calculate the interest rate on a mortgage, and then also allowed somebody to hack something. So any defect you find early stage is saving untold amounts of money that increase exponentially over the course of time. Then I want to propose automation across the DevOps test toolchain. DevOps test toolchain is, if you think about a 12-inch ruler. When I'm in Europe, I have to do centimeters. 12-inch ruler. If the 12-inch ruler includes, it sort of encompasses the SDLC, from design development, the 1 and 2, early development and unit testing, and then at some point you ship. That's the 12. Selenium, in my mind, occupies about 7 to 8 inch mark. That's where it should stay. It's being used all over the place in ways that it shouldn't, but it should stay right there. UI verification of rendering from API results. Like, it sounds so much simpler when you say it like that, but it's true. We're pulling back the camera and we're looking from 3 to 11 because we recognize that testing should be shifting left. We should be getting into API testing in Puppeteer, Cypress, Test Cafe, Playwright, UI unit testing, JavaScript unit testing, and then we should be pushing to the right, which means post-production. We just bought a company called Backtrace, which is a lot like Sentry in that they do error monitoring. They could bundle up an error and send it back to the developers and the QA folks to say, this thing happened that you predicted might happen because of what happened in your test environment. So we're correlating all these signals together because we believe that that's been the missing piece in software since software existed, is correlation of all these signals that traditionally have gone unanalyzed. If you think about how much data is flowing through a Selenium grid, it's a node on a grid is running a Selenium process. It opens up a browser, add a URL. Already, you've understood now the software that is coming from the backend servers, the API calls that are being made, as well as the code, the HTML, CSS, JavaScript that's being rendered in the browser. The Selenium grid node already has a lot of data. Then you start hitting it with intent from Selenium, and you say, here's what I want to do, here's what I want to try to do. Here's a thing that worked, here's a thing that didn't work. And meanwhile, there's a process that's running, and logs, and data, and stuff flowing through the proxies, and a whole bunch of API calls. And that has gone almost completely unexamined in the history of testing. To me, this is where we should point the AI ML guns, not at test creation. This block. The ability to pull insights out from what's already going on that you're missing out on. That would be a return on investment, to be able to pull that kind of data out. This is what I'm trying to get to with the DevOps test toolchain in terms of how do we get return out of testing. Because testing isn't just Selenium. It never has been, even though people treat it like that. It's API testing, it's unit testing, it's Puppeteer, Playwright, Test Cafe. I always forget one. Cypress. And then it is also instrumenting the application itself, not only for testing, but for good monitoring, as well as analytics. Using those analytics, bundling them up, and letting them tell the story back to the product people who define and gather requirements. And all of this stuff firing on all cylinders gives you what I'm starting to call like kind of this transformative confidence in your ability to ship quality software. I've experienced this once. At Retail Me Not, we had a series of processes where we were trying to upgrade our security, and we had to go through an orchestration like we had never undergone before, where we would essentially have people fire this feature flag, do this test, fire this feature flag, do this test, fire this feature flag, do this test, and then we automated all of it so that any future changes to the security would be able to give us the confidence that say, not only do we know that this passed, all the developers are on board with the fact that the automation is good and accurate. I have only had one project in my career where the developers actively watched the board to see if tests were red or green, because we stayed on top of it. Because and to me, I wouldn't be able to tell my CTO at that point, what's the ROI for test automation? I would just be able to show him that when the tests turn red, every developer looks at it. And you only have about 2 or 3 minutes of investigation before you understand what the root cause was. And you can turn it around and ship the fix behind a feature flag, watch it go to 2% of traffic, make sure it doesn't throw any errors, and then roll it out to the bigger audience. And that kind of confidence, you don't have to have someone waking up at 5 o'clock in the morning to do this, because that's the only time you can ship a change to production. The ability to ship these changes quickly without any drama will change the nature of how your team develops software. DevOps test toolchain to me is development, test, production. This is a very traditional through line of how software is developed. And then all of these different tools, so you have either Backtrace or Sentry, or you build your own. you have either New Relic or what was the other APM, like Sumo, something like that. You have Launch Darkly, you have Optimizely or Toggles, you have one of those. The DevOps test toolchain is that you're already chaining these tools together in some way to pull signals that are disparate and not well plugged in together. So you do this, you draw these lines between these things. You write API integrations, you pull things into reporting, you do things through the portal, you create reports that are nightmarish. And I was talking to AIG not long ago, and they showed us a spreadsheet of their 2-year plan to create this. There are 45 columns, a vendor and an owner for each column, the anticipated cost, the anticipated close time, the integration time, the API, everything. That tool chain that everyone is independently out there building, involving all these different kinds of tools. And what we are trying to do is build it ourselves. Now, what we want to do, I mean, once again, I'm not trying to do a pitch here. What we're trying to do is make a data platform that's pluggable. If you want to use Browser Stack for this bit, you want to use Applitools for this bit, you want to use App Center and TestFlight for this bit, the plugin, the data from the instrumented API, instrumented SDK, that'll get plugged into our data layer. But this is what we're trying to do, is give you not necessarily what they call a single pane of glass, but at least the ability to collate this information in a way that developers and testers have not previously had access to. And if you talk to developers that use a product like Backtrace or Sentry, they talk about already how transformational it is to be able to know instantly, once you've shipped software, what kind of errors were happening and how to get that information straight to the developer so they can get to root cause within minutes rather than days, the way it takes now. So this is how we define the DevOps test toolchain, and this is what I'm hoping to do eventually, once we can combine all these signals, to be able to give you an ROI calculator that uses the data from 4 billion tests that have run through the Sauce Labs platform and collate that ideally by vertical. So imagine I could tell you, medical, you get this kind of thing, defect, this kind of thing. The cost curves are going to be very different for defect shipping to production, that kind of thing. What we're hoping to do is finally start using all this data to tell the kind of story that I could only dream of when I was in industry. This is the best chart I found in terms of the cost of defects. So when they're introduced is the blue line. When they're found is the orange line. How much they cost is the red line. And every time I see that, I think I want to see that broken out by vertical. Because I think for a gaming company or an e-commerce company, that can kill your company. Sure.